Hi, in today's video we are going to cover some of the advanced elements of canvas. The first one is nothing but a filling property, that is nothing but a gradient style of a fill. Second are the transformation techniques such as scale, rotate and translate. Let us start with fill style gradient. Gradient is one of the style that can be used to fill a particular shape. Instead of filling a shape with a single monotonous color, we can use more than one color in their the shading part, so that shape looks attractive. So we can use this gradient to fill any shape such as rectangle, circle, line or text. We make use of a method create linear gradient to create one gradient. Now how to create this kind of fill style of a gradient? That can be done with the help of declaring a variable my gradient is equal to ctx dot create linear gradient method. Now this create linear gradient method defines four coordinates. First coordinate is nothing but x and y parameter from where gradient should start, and second two parameters are x and y coordinate of point where gradient should stop. So gradient starts from one place and transits to another place. So here as the second line displays my gradient dot add color stop, my gradient must start with black, that's why 0, black is given. Gradient should stop at color white, that's why the line my gradient dot add color stop 1, white is given, and in between at the middle point gradient should be in red color. That's why we are writing my gradient dot add color stop 0.5 red. It is perfectly okay that you define a gradient with only two colors, that is starting with black and going up to red. No white component is included. In that case, we will make use of 0 to black and 1 for red. I'll show you an example to demonstrate the use. Once the gradient is defined and color stops are added to it, we set fill style property as one of the gradient variable. So we write ctx.fillStyle is equal to, instead of specifying any color name in double quotes, here we are specifying gradient variable, my gradient semicolon. Now once the fill style is set, you can draw any shape using fill property, such as you can draw fill rectangle, you can call an arc method and call fill method followed by it to draw a circle. Here we are making a call to ctx.fillRect method where 20, 20 is the coordinate of top left corner of a rectangle. The width of a rectangle is 150 and the height of rectangle is 100. Let us look into this example working on a web page. So, in this example, we have one canvas, same formatting, same strategy we have followed. Within script, I must type is equal to, in double quotes, text hyphen JavaScript. And within that script tag, we are having one canvas variable C and one context variable ctx. We are defining one new variable, that is my gradient variable, that is defined using context dot, that is ctx dot create linear gradient method. The first two parameters are the x and y coordinate from where gradient should start. So gradient starts at location 0, 200. So basically I must write that x, y is the coordinate from where gradient starts, and x1 and y1 are the next two parameters where gradient should stop. So as you see, this is 0, 200, that means x displacement is 0 and y displacement is 200, that means somewhere in the bottom left corner of your canvas. And when we say 200, 0, it is top right corner of your canvas. So whatever the color progression will have, it will start from bottom left and go to the top right part. The transition will be in the same order. We are adding first color as our red color, second color in between at 0.5 as white color, and the last color is at 1 is my gray color. And we are setting this gradient variable as a fill style. So we are writing ctx.fillStyle is equal to grd. And using this fill style, we are calling a fill rect method. So one rectangle is created from 0, 0 to 300, 300. Note the width of rectangle and height of rectangle. It's 300, 300. So just look at the web page how gradients are being displayed. Here, as you can see, a rectangle is of 300 by 300 size, and 0, 200 is my bottom left point and 200, 0 is my top right point. So the gradient is in diagonal form from lower bottom to right upper. If I want to change the direction of gradient, I must change its coordinate. So for example, to change the, if I am changing the coordinate, when I write 0, 0 to 200, 0. Now 0, 0 is the top left corner and 200, 0 is top right corner. So gradient will transit from left to right. Now I am saving this page, going to web page and see and notice the difference. Now as you can see, it starts from left side and it is transiting towards the right. Now if you notice carefully, the portion of gray color is much more as compared to red color. It is because we have defined a gradient up to 0, 200 and the width of a rectangle is 300. So the pixels between 200 to 300, all pixels will be followed by the same color from where 200 pixel has ended. So if I reduce the size of rectangle as to the size of gradient, then all colors will be in equal parts. Let us experiment that. So instead of changing rectangle size, let me change the gradient value and see the difference. Here, as you can see, now the portion of red, the portion of white and the portion of gray is same. How can I have a transition from bottom to top? That means from top I must start with red in color, in middle I want blue or say white, and at the bottom I want gray. So that transition can be done between the point top left and bottom left. So top left point will be 0, 0 and bottom left point will be 0, 300. So I will save this code, go to web page, refresh and notice the difference. Here as you can see, it is from red, white and gray horizontally. So this is how we are making use of gradients. I can make use of more than 3 colors in my gradient. To add one more color, I will again add one stop at say for example 7, 5 and be that color be blue. So the transition will be now from red to white, white to blue, blue to gray. Save and check it. As you can see, red, white, blue and at the end gray. The very first transformation technique is scaling. To scale some drawings, we make use of scale method. This method is basically used to make any drawing bigger or smaller than its actual size. If you scale some drawing, every drawing followed by that scale will be also scaled. So for example, if you want to scale only one rectangle and after that whatever shape you are drawing should not be scaled, then you should reduce or make bigger, restore your scale. The positions will be also scaled. For example, if you are referring 5,5 in original coordinate, it is actually referring to 5x coordinates and 5y coordinates. But once I increase my scale to the twice, 5,5 will be actually interpreted as 10,10 because each coordinate will be now doubled. The syntax of using scale is ctx.scale, scale width, scale height. If you are giving scale width as 1, it is getting magnified as 100%, that means in its original size. If you are giving scale width or height as 0.5, its size is getting reduced by 50%. If its value is given as 2, its size is getting bigger as in twice. If you are giving value 3 as in scale or width or height, it is getting 3 times bigger. 0.1, your drawing will be reduced to 10% smaller. So, to draw a rectangle, we will see an example to draw a rectangle which can be scaled to its twice of its size. We will make use of ctx.stroke-rect 5,5 with its width and height 25 and 50. ctx.scale 2,2. Every shape will be in a twice bigger size. ctx.stroke-rect. Now the second rect method, stroke-rect method, every value will be get doubled. That means 5,5 is now 10,10 understood by browser. Okay, and 25 will be now interpreted as 50. 15 will be now height interpreted as 30. So if you notice carefully in this given figure over your screen, the gray rectangle is having starting at position 5,5, having width of 25 and height of 15. Whereas this black rectangle, which is the scaled one, which is drawn using the same coordinates 5,5, 25, 15, but appears bigger. Its starting position is also shifted because the starting position is now 10,10 just because it is scaled by 2,2. Its width is now 50 pixel and its height is now 30 pixel. So let us exercise this particular method. In this code, we have set first stroke style to gray to draw a rectangle in a gray color. We have stroke rect method. The starting coordinate or starting top left corner of first rectangle is 5,5, width is 100 and height is 50. So just in case you won't be able to see 25 by 15 rectangle very big and notice the difference. That's why I have increased its width and height. So width is 100 and height is 50 pixel, and we have scaled up by calling ctx.scale to 2,2, and we have changed the stroke style into blue so that you can see the difference between the color with the help of color. Okay, so ctx.stroke-rect 5,5, 100, 50. If I have not used this scale, then both of these rectangles will be drawn one above another. First gray rectangle will be drawn, and over the same place at the same location, same coordinates, blue rectangle will be drawn. But just because I have scaled it, two different rectangles you will be able to see on your screen. Let us see this. This gray rectangle starts at 5,5, width is 100 and height is 50. This blue rectangle is slightly towards the right and towards the down, that is at 10,10. The width is also increased from 100 to now 200, and height is also increased from 50 to 100. So my next blue rectangle appears bigger in size. What will happen if I scale my drawings again by 2,2? Then all the drawings will be now 4 times larger than its original coordinate positions. Say for example, I again scale this particular context. I set my stroke style to red and draw the same rectangle with same coordinates. Once more, I am scaling the canvas, setting its stroke to green and drawing the same rectangle with same coordinate. I'm going to notice the difference over the web page by saving and refreshing the web page. Saving this file and refreshing the web page. Here we go. As you can see, this red rectangle starts at 10, 20, 20 instead of 10, 10. So the difference or the relative position is going to increase. So the distance between gray and blue rectangle is very small, and this distance is getting doubled between blue and red rectangle. Similarly, the distance between red and green rectangle is twice as the distance between the blue and red rectangle. And you also notice that this green rectangle is so big that it is going out of the canvas. Canvas is not that large to display its complete size. Okay, so the conclusion over here is whenever you do 2, 2, it is doubling up your coordinates by its twice size. What will happen or what I should do to reduce the size of this green to my original? So to do that, I'll go back. Instead of scaling to 2, 2, I will reduce it to some size, that is 1.5. Okay, make it half, that is 0.5 to 0.5. So what will happen? Initially gray rectangle will be displayed. Now scaled blue rectangle will be displayed. The larger red rectangle will be displayed. Now whatever the coordinates are of red rectangle is, then we are reducing our coordinates to the half. That means we are again going back to the scale size of this blue rectangle. So we must not be able to see blue rectangle now because green rectangle is drawn above exactly above the blue rectangle. Saving this, as you can see, even though blue rectangle is there, but I am not able to see it because after this red, I have reduced my size to 0.5. That is, we have reduced our scale to half of its size. What if I reduce my current scale to its 10%? So I'll make use of 0.1.1. As you can see, now my green rectangle is at the behind. It's very small that you are not able to see it. Okay, I'm zooming it. Okay, so this is the green rectangle that you are looking at. Let me reduce everything by half of its size and see how it looks like. Here you go. The original grey rectangle is the largest one now because now we have reduced our scaling to half. So my blue rectangle starting position, even though specified as 5, 5, it will be approximated to 2.5, 2.5. For red rectangle, it would be 1.25, and for the green one, it will be much smaller, even not able to see it, right? So we do not have that pixel, that smallest pixel, 0.0 point something, 000. So this is how scaling works. It is obvious that you can scale down in one direction and scale up in another direction. That is perfectly okay. You can keep the current scaling as in width and you reduced in size. That is also okay. Let us see one example. Now, as you see, okay, the gray is the original rectangle. For this red rectangle, I have changed only width is reduced to half, so the size of red rectangle is half of the original gray. And for the blue one, I have kept width as it is as of red, but height is now increased to twice. That's why it is twice longer than the red rectangle. Another interesting transformation is rotation. Rotation can be performed using rotate method. To rotate a particular drawing primitive such as a particular rectangle, line, text, we make use of rotation method. Rotation will only affect those drawings which are drawn after the rotation. So we must first call rotate method, then only we will draw a particular drawing. Then it will be rotated. It's not like that first you draw and then call rotate method and the previous drawings will get rotated. No, it's not like that. So the syntax for rotation is ctx.rotate in bracket angle. Now notice that this angle again, just like your arc method, must specified in radians. It should not be specified in degrees. So the method to convert your degrees into radians is degree into math.pi divided by 180. For example, you would like to rotate a rectangle by 5 degree, you would write 5 into math.pi divided by 180. Now this example that appears over your screen is a rectangle, that is filled rectangle, and it is rotated 20 degree from this point. I'll show you from where it is getting rotated. Okay, so this is the point, top left point, which is actually its current point, 50 comma 20. Okay, so this 50 comma 20 is this current point. The width of rectangle is 100, this width is 100, and the height of rectangle is 50. So when we draw simple filled rectangle, it would be having this width and this height. This would be the original rectangle, but it is getting transferred, it is getting rotated by how many degrees? By 20 degrees. Now this 20 degree must be in clockwise. As we have discussed in our arc, this is your 0 degree. Whatever radians that you are specifying will be measured towards the left hand side, bottom left hand side. So this is your 0, 0 and this 20 degree is getting measured and converted into radians, and this reference line will be created and it will draw this particular rectangle which is being given by this black color rectangle. So this must be very much clear that whatever angle you are making, that angle is in reference with your top left corner. So this is actually 20 degree and this point is your 50 comma 20. Now in this example we have one simple fill rect method where initial positions are 50 comma 20 and width and height are 150 respectively. But before drawing or calling this fill rect method, we are rotating our canvas context. Now this rotation is in 20 degrees, that's why we are writing to convert in radians is 20 into math.pi divided by 180. And the color of filled rectangle I want is red. You can just simply skip this line if you don't want. It's not actually required in this demonstration. So we will save this work and view it in a web page. As you can see, this gray rectangle is at its original position and this pink rectangle is translated to new location from 70, 70 with 10, 10 addition, it's at 80, 80. If I want to add one more rectangle at this location, whatever the rectangle now onwards I will draw will always be translated unless and until I restore them at original location. So let me experiment something. Instead I will add one more blue rectangle. Now this blue rectangle is having same coordinates 10, 10, width and height is also same. But just before drawing this rectangle I am rotating this rectangle 10 degree towards the bottom. So let us see how it looks like. So refreshing this page, as you can see now blue rectangle is at new coordinate system which is translated at 70, 70, but it is now rotated at down at 10 degree. If I want to add more rectangles, say for example I will again add pink rectangle which is more 10 degree rotated. So eventually this pink triangle will now 20 degree in total get rotated. So saving this work, observe this one more pink rectangle which is 20 degree rotated. Just copying pasting this blue pink alternatively. So in total we have 6 rectangles. So saving and refreshing this will give me result this way. The original rectangle we stored any translate and 6 rectangle after translate, but each time we are adding the rotation of more 10 degrees. So that is all for today. In today's video, we have covered gradient filling method and three transformation method, scaling, rotation and translate. Thank you everyone for watching this video. This is Munira Topia signing out.